Awesome. Thank you for starting the recording, Ben, and welcome everybody. This is the October meetup of the External Secret Operator crew. We have these meetups at least once a month. We're hoping to have them in person sometime next year. And before we get started with anything, I would just like to remind everybody that we do have a code of conduct. You guys can scan the QR code or follow that URL. The code of conduct is pretty simple, pretty straightforward. Be nice, play nice. And if you aren't one of us, we'll come have a chat to you. Tonight, we've got two speakers that will be joining us. We've got Gustavo giving us a project overview or project updates, which is just a nice collection of things that we've released recently. And we are also joined with Lucas Severo from Red Hat, and he's going to be talking about threat modeling for secret synchronization at scale. But without any further ado, I'll hand over to Gustavo.
Thanks, Charles. So hello, for anybody that doesn't know me yet, I'm Gustavo. Nice to meet you. I'm one of the maintainers at External Secrets Operator. So the project updates that I want to give here are kind of small. I'd say this release was a little bit smaller compared to the other ones that we had. It was mostly bug fixes, but we do have some new topics. So going further, can you please go for the next slide, Charles? Thanks. For me, this is probably the biggest feature that we didn't know that we needed until we needed. We now have released a new metric in External Secrets, which is the reconcile duration. This allows us to check how many seconds takes from one external secret job to reconcile. This was one feature that was contributed in from the community itself in a deployment with over thousands of secrets being reconciled by external secrets. So this is a very cool feature that came out from the need of a very production, I don't know, tough production scenario. So that's very cool. For the next feature, this one is also something related to production environments. When we have external secrets running against some providers, for instance, either HashiCorp Cloud or AWS, whenever we do a token request, we actually pay money for that request. The issuing of a token itself costs in terms of these clouds. And for these two providers, we now have the option to store that token for a while, do a token cache until the token is no longer valid. So this means that you can run External Secrets Operator in a cheaper way. For now, this is still experimental. We are testing out just to see if we don't introduce any breaking changes. If it works as expected, our plans is to actually roll these out to every provider and make it default. So it's a cool feature to make your deployment cheaper. And yeah, it's nice to have. And lastly, this is also a community-driven feature. We added a new provider. This provider is Doppler. I think that's how it spells it. It's based on the Doppler.com secrets provider solution. And with that, you can easily connect ESO to there as well, just like that. These were the main project updates that I wanted to give to you. Just like I said, not very many of them, right? But it's nice to know and also to give us a little bit of accountability that we are actually moving forward. So with no longer belongings, I would like to bring here Lucas as well. Lucas is going to do our guest presentation here. So if you want to introduce yourself, Lucas.
Sure. Thank you, Gustavo. So yeah, my name is Lucas. I work for Red Hat as a software engineer, working mainly on OpenShift core and upstream's contribution and bringing things downstream to OpenShift. But also I'm a maintainer at External Secrets Operator. And together with Gustavo, Moritz, and a bunch of other people, we try to push the project forward and to spread the word and all that. So yeah, here I'll be talking mostly about threat modeling. I can share my screen. I think you have to stop for me to be able to share. Okay.
All yours.
Did it work?
Yes, we can see your
Yes.
screen.
Okay. 1 sec. Okay, so this talk was supposed to have 2 parts. The first part was supposed to explain external secrets and explain secret management in general and talk about all the topologies and all that. But since we are in an external secrets operator meetup, we decided to kind of skip that part and go straight to the threat modeling. We can, of course, go back to it if it's necessary. And the idea about talking about threat modeling came from a bunch of statements and questions that we get quite often regarding like security and what is more secure. And some statements that we hear like this approach is more secure than this other one, like always, or ephemeral volumes will always be more secure than Kubernetes native secrets, or anything that is a very blunt and direct statement like that. We would like to challenge that because external secrets, as probably everyone in this call knows, works with Kubernetes native secrets. And we, of course, think that that can be secure as well. And we'll talk about threat modeling, exploring that. And the first point is that like making these kinds of statements, it's complicated because context matters. Like you have to understand what is your environment, what type of enforcement of policies you can make in a lot of teams, the size of your teams, the size of a company, how you can make people follow some standards and this kind of stuff. So how you look at the problem, what are your requirements, what compliances you have to adhere to, what are your company policies. Everything affects what you choose. And like choosing something just because it sounds safe, it's very dangerous, in our opinion. And then because of that, the thing that we'd like to show actually is like, okay, going through a lot of threat scenarios, would it make such a difference to use different synchronization solutions? So here looking at external secrets operator, the one that we talk about the most here at this meetup, or HashiCorp Vault, Sidecar Injector, or Secret Store CSI driver, or any synchronization solution. Within these threat models, would it make a difference? And then we'll make some conclusions and how to actually make things safe based on that. And then, of course, there are a lot of other threat scenarios. Of course, these threat scenarios, you can make them more complicated, of course. And yeah, but we would like to show that these are like the things that come straight to mind. And I think it makes sense to explore them. And then the first threat scenario is attacking your cluster through the Kubernetes API. So basically, when you run kubectl, you're talking to the Kubernetes API, or if you're using curl, just hitting the API itself and this kind of stuff. And looking through the Kubernetes API perspective, we'd like to show that, like, if secrets are on ephemeral volumes, if secrets are on, I don't know, on Kubernetes native secrets, if secrets are injected to the memory via sidecar injector, it doesn't make that much of a difference if you have the roles or you have the permissions to get things from the Kubernetes API. Maybe it's because of misconfiguration on your role-based access on RBAC, or maybe it's you're not using, or maybe you're allowing everything, or maybe you're using open policy agent gatekeeper or Kyverno, and that's misconfigured. Or maybe the Kubernetes API has a new CVE that's allowing people to get that. And everything in this space would allow you to get something. And then from the Kubernetes API perspective, and then here, of course, we are talking and comparing mostly external secrets operator and secret source CSI driver as an example. Like if secrets are on ephemeral volumes, or secrets are as inside a cluster as Kubernetes native secrets, if you have the rights to get that, so if you have pod exec create, you can exec get a shell of a pod, and you can see everything that is in there. If you have secrets or volumes get, you can get that data, and you can JSON path it and basic C4 decode it. And then the argument here is that from the Kubernetes API perspective, you can have access to that. It doesn't matter that much if it's in ephemeral volumes or if it's in Kubernetes native secrets. And one thing that is interesting here that we discussed a few times is that it's more common, even though it's not necessarily advisable, for you to have exec create to pods, because developers maybe want to debug something, like grab a shell and see what's happening. Then getting secrets, like have the verb get of secrets inside a cluster. So it's more common to have the other one, but with the pod exec create and grab and shell of a pod, you have access to everything that is there. And then the second scenario is a bit, it has some premises. So let's say an attacker gains root access of your worker or maybe your control nodes. And then a lot of things can happen before this, of course. Maybe it's a vulnerability on your front end, and then the person can inject something, then grab a shell of a container, then escape the container, then escalate to be a root of this node. And a lot of initial attack vectors can happen before you can have this. But considering that the person has access to this and can install a tool like mextract and like read the whole RAM, the whole memory, it will get access to everything. It doesn't matter if it's like environment variables, if it's an ephemeral volume, if it's a Kubernetes native secret that is attached to the pod, if it's injected into the pod memory via sidecar injector, it doesn't matter. The attacker has everything, if the person can interpret this data, of course. And then the third scenario is a bit full of information here on this slide, and also it's a bit controversial, let's say. I think it's the most discussed thing on Kubernetes, not necessarily security, but like best practices that people talk about when you're bringing a cluster to production. So people say, okay, you have to encrypt your etcd. But then these first two scenarios here, so the first one, etcd is unencrypted, and if a person gets access to the node, it will have access to all the data. In the second scenario, the person has access to etcd, but it's encrypted. But then the person that encrypted it, the etcd node, just follow the standard procedure, like documented, and you leave the key in the same node anyways. So that's the official way to encrypt etcd. And the person that has access to the node has access to the key, and with the key, the person can decrypt the etcd anyways. So this is mostly placebo, in my opinion, at least. And then there are a lot of other ways to do this. You can use KMS with auto rotation. You can use network-bound encryption. And then this will be more secure. Of course, there's always this thing about security, like it's indirection, maybe it's just obfuscation. Skilled enough attacker would mimic what etcd is doing, like monitor it and then mimic it and know how to get the keys and decrypt it anyways. So, but then at least you have like multiple layers of indirection and obfuscation here, then it would be a bit more secure. And then, but the argument here is not necessarily about this, it's just to show that things can be insecure anyways. But the argument here is more, okay, you're worried about etcd being compromised. And then one of the things that people ask a lot to us is, okay, but external secrets operator stores Kubernetes native secrets, like the end product of it. It's like creating a Kubernetes native secret inside a cluster. And then we are concerned because etcd can be compromised. But then my reasoning here is like, okay, if etcd is compromised, a lot of sensible data will be available anyways. So if it's, and then we are comparing tools here, of course. Any tool that has to store something on etcd, so if it's a CRD, if it's service account tokens, if it's like authentication credentials to like talk to external providers, everything will go to, if it's going to etcd in any stage of the steps that the tool needs to do something, this will be a problem anyways. And then having secrets or not on etcd will be the least of your problems. And then this is interesting because and it's something that changes depending on what you're using and what version of Kubernetes you're using. So service account tokens before 1.24, they were more permanent, if I could say that. And nowadays it's a bit more ephemeral, if we can call it that. But you still have a lot of power when you have etcd compromised. You can like scale your role-based access and get a role that you will have powers to do stuff. So yeah, etcd is a how can I say, a polemic thing. But yeah, compromising etcd, like having secrets on it, it's not the thing that will make you more or less secure. And then for scenarios like having physical access to a server, here we're thinking about, like, of course, bare metal, or in your company, data centers and this kind of stuff. And if the person has access to the physical server and then has access to the key, if it's etcd, you already saw what could happen and what people could do. But then if it's worker nodes or control plane nodes, there are a lot of branches that could branch out of this diagram, but most of them can be mitigated with disk encryption, of course. And then the other one, like having access to the physical server as well, but then an extra PCI slot. You can also read all the memory, like all the RAM, and then you have all the data unencrypted because the thing is turned on. And then the fifth scenario, this one is interesting because this is a CVE that will always be open for Kubernetes because it's by design. So if an attacker gains access to Kubernetes with sufficient role-based access, and then creates a cluster IP service with a relevant spec external IPs, the hacker can like create a scenario where he could read anything that is happening like in this service. And then with this, you can create a scenario where you have a man in the middle reading every call, and like every call to get a secret, even calls to the secret manager themselves, to like a AWS secret manager or to Vault. So this is not necessarily only inside the cluster, but also outside. So this is a vulnerability that, of course, you can just deny RBAC privileges to like users and developers and attackers not be able to patch their services. And then this is done. Or yeah, you can like create some other ways to avoid this, like thinking a bit more about network security, and maybe some advanced admission controllers as well. And then the idea of going through all those flat models, of course, those were just 5. You can think of other ones and make those ones more complicated, is that it's very hard to have a silver bullet. And here it's just a slide showing a silver bullet being shot at a swarm of bees, and silver bullets only kill vampires, and vampires don't exist. So it's a complicated thing. And then the argument is like, okay, the most important thing in the end is understanding requirements, understanding the compliances that you have to adhere to, the company policies that you have to adhere to, and understanding if they are like hard requirements, if you have something that is a not requirement as well. So here, let's say we need to be able to enforce in every team. We should be easy to use. We need to integrate with multiple providers, and on and on and on. But then there's a not requirement as well. Okay, avoiding secrets in etcd is not a requirement. And then it makes sense to choose like right away external secrets operator. We can have like multiple multi-tenant setups and like advanced templating and all of that. But then there are some other cases maybe. So let's say in this company, there's this team, specific team, that they need to be sure that the secret is in a single place inside their infrastructure. And this secret cannot be in a TCD, like it's explicit. It's a company policy. This will never change. It's also something that will be hard to argue against and make sense to use secret source CSI driver for this team. But then in the same company, all the other teams could use external secret separator. So they don't need to avoid secrets in etcd, but they need advanced templating. They need like to have the feature to like spread secrets across multiple namespaces and controlling that in a multi-tenant way. So this is also something that makes sense, and we saw some people do. And then there's always the case where you will have to use secret store CSI driver, and this makes sense. Sometimes that other topic that I mentioned before. So there's like this policy. We need to be sure that the secret is in only one place in our infrastructure, and it's not in a TCD. And we need to like always, because of compliances or company policies, know where the secret is, and then it makes sense to use secret store CSI driver and only this, and it will make sense in every case inside this this scenario. And then you can always have some other cases that other secret solutions would make sense. And we say this because I think people make sealed secrets get a hard time nowadays. And it makes sense to use sealed secrets as well. So you need the simple solution. You need like a GitOps compatible solution. But like you have this not requirement. We need needing to avoid secrets in Git repositories, like encrypted secrets in Git repositories, is not a requirement for you. And it makes sense then to use sealed secrets. And like talking about this, and okay, but then what's the end game here? Like, so how can external secrets operator deliver some security if we're making the argument that secret synchronization solutions don't play that much of a part, like in security itself? And then we believe that external secrets operator delivers security because, well, the first thing I think everybody when are looking for this kind of solutions, you're thinking, okay, I don't want developers or people that are like coding or creating the solutions or even some parts of operations. I don't want them to have access to the secret values themselves. I want them to only have access to secret references, only to manifests that will tell the operator where to get the secret. Also, you want to make this easy to enforce across multiple teams. So security is also about standardization, make security something that will be possible inside your topology and your teams. And then having a lot of features that will make people want to use this. So complex multi-tenant setups. So making operations don't have to think about this multi-tenant setups as something complex, because external secret operator will make this easy to spread secrets in a way that makes sense. And then enforce usage and a single operator in your cluster and all those nice things. And the idea then, in the end, like the thing that I like to say, okay, the secret synchronization solution that you're using is way less important than three other things that I like to list. Like access management is way more important when we're thinking about secret security. Good identity and security boundaries, like good topologies, good separation of environments and tenancy. This is also way more important than the secret synchronization solution that you're choosing. Or even so, the avoidance of initial attack vectors. So the things that we in any of those threat scenarios, we could see that the avoidance of initial threat vectors played a lot more part, and of course access management. I think in almost all of them, access management was something that you could already think of. Okay, if we created a role that didn't allow this, it would make much more sense. And then this is the argument. Okay, you want to make secrets secure, you want to avoid people getting your secrets. Of course, you want a secret synchronization solution because you want to make this easy to use and like easy to spread. But the three things that you need to worry about is access management, good security and identity boundaries, and avoidance of initial attack vectors. And then we listed some other things here, like encrypting the TCD and leaving the encryption key in the same node. It's mostly possible, and it's the official documented way to encrypt the TCD. Like the things that you need to do, like maybe you want to install a advanced admission controller to create like very complex rules to decide who or what has access to what. And you need to keep looking at CVEs. You need to know them and you need to monitor them all the time. That's the reality of it. Like kubeAPI CVEs, container-related CVEs, if it's Docker, if it's containerd, or any container runtime that you're using. And of course, and this is a very nice thing, people think of security and usually they only think about prevention. And maybe, like my opinion at least, you need to think way more about response. So your secrets will leak. That's a thing that you need to assume. And you need to have a way to rotate your secrets like easily. And of course, Kubernetes external secrets operator delivers that, and a lot of other solutions will deliver that. But you need to like make plans and create a process for that. And you also need ways to like turn off everything in a way, like to pull the plug. So one thing that we had to create in external secrets operator was a way to, when I don't know, operators would, developers or DevOps or SREs would delete secrets from the secret manager itself, like from Vault or maybe from a AWS secret manager, we, external secrets operator, would also delete the secret on the cluster because people wanted this pull the plug thing. Okay, I want to delete we know that this secret's leaked, let's say. We want to delete everything here and we want like the secrets to vanish from the cluster, like, and then create the rest of the response process that they were thinking about. And then I can jump this and go to this. I think Gustavo already gave most of the updates. Things that you could look out for that are coming are push secrets. There's a very big PR and mostly ready to merge. If it's not merged already, Gustavo can correct me. Generate secrets as well, so secret generation. And we plan general availability end of 2022. And of course, we need contributors and maintainers. We now have a governance process and some steps for people to become maintainers. Of course, if people want that, it will be easy, and we want more maintainers and help, so just talk with us. And I think that people here in the meetup already know our Kubernetes Slack and also the website and the repository. And yeah, I want to hear some questions. Gustavo, if you have anything that you'd like to add also, because we created this talk kind of together, Moritz as well, but Moritz is not here. Feel free to chime in.
Thank you so much for sharing, Lucas. If you don't mind, I'm going to take a screen share because I've got a couple of QR codes for the developer guide, the contributing process, and a few more details.
Did it? Okay.
Lucas, can I ask a couple of questions? I think it would be good. I've got one very specific question, which is about my understanding, but then it would be good to understand more about generate secrets, and for the people who are here to understand exactly what generating secrets is going to mean in terms of ESO. But I think first of all, I wanted to ask about the third threat that you showed. So this was the threat around the things that are available within etcd. And when you put up the slide comparing what's available with CSI secrets and HashiCorp Vault Sidecar and ESO, it was only ESO that made secrets available in etc.d. But to my mind, when you have a secret that you need an application that's within a pod to use, how is it that you can make a secret? Let's say it's a secret that's going to be used to authenticate against a third-party provider, like an API somewhere else. Would that not be available within etcd? Why is it only ESO that makes that available?
Yeah, with Secret Store CSI driver, they mount the secret directly as a file, as a volume in the pod.
Mm-hmm.
So they read like from the external provider. There's nothing in etcd, like at least the secret itself. It goes directly as an ephemeral volume to the pod.
Right.
But the thing about this slide is like you still have things in etcd that could make you have access to the secret outside anyways.
Yeah.
So that's the argument. But with the Vault Sidecar injector, they also don't create secrets. They inject as environment variables or as volumes into the pod.
Mm-hmm.
Go ahead.
Just to give a compliment here, the thing about the fact that these tools are kind of equal in that sense is that CSI, Secret Store, and Vault Injector, they both get the secret information, the sensitive information, using the pod's service account. So that same service account is available in etcd. So whoever got access to that etcd could simply get the service account, pretend to be the pod, and do the same things. That it's like the secret is there, we just have another step.
Exactly.
And
But
can you
go ahead.
Can you paint that picture about what generating secrets is going to look like in the context of ESO?
I think Gustavo has more context than I do.
For sure. So the idea of generating secrets, it's a PR opened by Moritz and mainly led by him. The idea is that some secrets, the nature of them should always be ephemeral and not really a static secret. We strive to have all of our secrets as ephemeral, but some of them we still need them as statics. That's why we have secret stores. But for those other types of secrets, for instance, credentials to connect to post secrets, to artifact registries, to image registries in general, eventually certificates, eventually database passwords that we want to keep rotating. So anything that is ephemeral, the idea is that external secrets will connect to a secrets provider, generate that ephemeral information, and make it available in your cluster. And whenever the reconcile loop happens, a new information is generated and already synced into the cluster. So the rotation here would be done automatically for those information, for those sensitive information that we want to rotate every X amount of time. Use cases for this, ephemeral image registry tokens. This one is like the most cool one because it's a feature itself within Kubernetes, but also to the extent is to generate credentials to connect to the secret providers themselves, making the secret store credentials itself ephemeral, which is also nice.
Yeah, and from what I understand, we are also using like endpoints, like features from these providers that they provide to generate like a specific type of secret randomly.
We even have some built-in generators. For instance, if you want to generate a random password, you can simply now do it You will be able to simply do it with this generator feature. It's very interesting. The PR is still open. We are basically testing it. The PR needed to change a lot of the code base. So currently we are testing for regression just to be sure that we didn't lose any features, any functionalities already existing, to then go to the new feature itself.
Question, Gustavo, by the way, about the. I actually have a question for Lucas as well, but latest one, Gustavo, when you mentioned the ephemeral secrets, how is that different from if you have like a refresh interval, or like when the external secret changes when you change some of the specs of the secret, since they depend on what's happening on the provider secret?
If we take, for instance, ECR, or I forgot the name of GCP ones. If we take, for instance,
GCR.
yeah, GCR, which is an artifact image registry. Each image registry, we can create tokens to access that specific registry, right? It is something that we can create long-lived tokens, but then it is normally very painful and very problematic when it comes to security, because if those tokens leak, someone might tamper the container images itself with some crazy processes that could be very hard to track and find if you don't have a whole supply chain security in place, which is also expensive. So the idea is that instead of having those information static, normally you create one, you put in your cluster is up and running, you'll never change it. We keep that dynamic. So every time that every given 15 minutes, 5 minutes, 1 minute, your security requirements will tell you the time. A new token will be generated. The old one will be useless, and this new token will already be available for Kubernetes. So from the Kubernetes point of view, the communication with the registry will still work. But if that token for any instance leaked due to someone committed it, someone downloaded it for some reason and made it available online, the range, the time available for the attacker to do something with it is very, very, very minimal. That's the idea. This could even extend to databases, for instance, but then the application itself will need to be a little bit clever as well to handle that. But it is a feature that could allow we take ephemerability of secrets to the limit if we wanted to.
Yeah, if you can add something, like you mentioned, reverse interval, like what we had before is what had something missing. So we had a refresh interval, and this was supposed to deliver a feature for people that wanted a secret rotation, but we didn't have the secret rotation itself automated at that point, like before this feature that we have now. So before, if we had wanted a secret to change, we would have to go into, I don't know, Google Secrets Manager and change it. And now you have this changing automatically as well.
Okay.
That's a nice way to say it. It's basically we handle the whole rotation life cycle now.
Yeah, nice.
We intend to. That's the goal.
Yeah, and if it's okay, if I can segue with no context to you, Lucas' question. Yeah, first, thank you for the presentation. That was really nice to see all the attack vector. Thankfully, we're on GKE, so maybe etcd is not part of that. So one less thing to not think about. I had a question when you mentioned this idea of like vanishing secrets. I don't know, like if this is a feature that is already available, or like when you mentioned if a secret is deleted from Google Secret Manager, and if that is detected as a not found, then the secret in the cluster will go away as well. But I was wondering, how does that work from like a GitOps perspective? If you have that manifest still there, so maybe Argo CD, I don't know, will keep thinking that it needs to have the external secret and secret store available every time it's deleted. Like, how do you think that could work?
Yeah, thinking about GitOps, the best way, if you wanted to like roll out a deletion, would to commit this deletion into repository, then this would trigger everything. But we wanted this to be a bit more like if external secrets operator can find, like has like a valid response and can't find the secret
Yeah.
in the external provider, it will
Yeah.
delete the, because this was a security requirement
Yeah.
from some people, some
The-
users that requested this.
The
But
idea
yeah,
from
that-
the GitOps perspective is that the external secrets and the secret stores are intentions. Is I want to have that secret in my cluster,
Yeah.
wherever that secret is stored. So
Yeah.
you didn't change that intention. So your
Yeah.
manifests are still in your cluster. What happened is that the secret itself is no longer there. So by default, external secrets operator behavior will be simply to error out. It won't delete the secret that it generated from the cluster. It will just error out. But you have the possibility now to opt in to a deletion policy, which will delete the secret as well. What it means is that whenever we don't find a secret in the provider, if you configure it, external secrets operator will say, hey, everything is cool, the secret is deleted. So it's a new status saying this external secret object is fine because the secret is deleted. And whenever a secret is created, it's going to be also to a valid state because the secret was created.
Okay. No, I think I understood that part, but I was wondering, like, how would you like as if like if you work with the cluster, how would you know that secret is not there? So like to have that feedback loop and make sure the external secret manifests are deleted from GitHub as well. So you don't keep on deploying them, secret is not there, external secret deletes the manifest from the cluster, GitHub pushes it again. So do you think like you can have like a notification system there? So
the external secret object will still be present in the cluster.
Okay.
But the secret, correct me if I'm wrong. The secret itself will be deleted. Yeah, only the end product.
Okay, the end product. Okay, now I get it. Thanks.
Yeah. And you will have feedback with messages, like with logging and probably events as well, I think.
Yeah, okay. Oh, that's nice.
I believe there is one of the metrics that ESO exposes is the number of synchronization failures. So if you were to see a sudden spike in those, you could obviously draw to it that a secret is missing or similar.
Yeah, the way that I see is like maybe with Vault or some other secret managers, you know that like a whole path of secrets is they are compromised. You delete like the whole path and everything will vanish from the cluster. So I don't know, because you have this kind of directory mindset inside of it, and you can delete a whole path and you can see everything vanishing. That was the thing that people asked for.
Okay. Very nice. Thank you. That was very clear.
Thank you for the questions.
I have a few questions. One quick question, actually, if I may. First of all, sorry, I was the one sneezing. I didn't realize my mic was open. Thank you for the talk, Lucas. I was late because I was actually looking at Rodrigo's presentation on external secret operator. But I have a question regarding the secret generation and rotation that you guys mentioned, and those ephemeral secrets. And I didn't get, it wasn't clear for me if that secret generation is still going to be pushed to the provider, or is something that's going to be handled between the external secret operator and the cluster itself?
It will be pushed.
It will be pushed. So
there are some exceptions. The generator configuration will kind of work like secret stores, and we will have secret stores that will only work in memory. So for instance, the password secret store will generate a password only in memory in an external secrets operator. But other generators will actually push the information to the provider.
When you talk about these generators, what are those? Are we going to have different kind of generators for different secrets?
Yes, the idea is to have the external secret manifest today only binds to secret stores. Yeah. This PR will make it possible to also bind to generators, which is going to be a new CRD. So you
Oh,
can
cool.
have the password generator, you can have the ACR token generator, the ECR token generator. Eventually, we want to get to the point to have the AWS credentials generator, and so on.
But
Oh, okay.
for now, I have to look again at the pull request, but for now they are in line, right? Not
No,
a separate
you
custom
can have as a custom resource definition and inline in the code,
and
in
in
the
line.
external
Okay,
secrets
yeah.
manifest.
Okay, yeah.
I think the next big step there is HSN-backed key generation through ESO.
Right?
Not too
Yeah.
far a stretch, huh?
Cool. Thanks.
Thank you. Any other questions?
I'm just thinking that this generator will allow me to get rid of the Vault agent that I'm using right now.
Yes.
Nice.
You
Nice.
need the evil genius laugh to go with that, Seb.
I just want to thanks a lot, Lucas, for giving the talk.
Thank you.
Yeah, thank you.
Thank you for the opportunity. And it's very nice to see some familiar faces here. And yeah, it was very fun.
Yeah, thanks a lot, Lucas. Yeah, thanks. Everybody else who we haven't heard from, I hope you've enjoyed being here. And if you've got any other questions, don't be shy.
Yeah, please join the Slack and yeah, start discussions at the repository or just ping us directly.
The last item I'd like to add in is we do have a feedback form on Google Forms. If you guys would like to fill it out, it always helps us just be able to improve our meetups going forward.
Cool. Thank you, guys.
Awesome.
Thank you.
Thanks.
Bye.
Thank you.
Take care.
Bye.